Alright. Let's see. What have we got going on here? Am I up? Okay. So, past 23 city builders. Oh my goodness gracious. Let's see the JavaScript news. The year in JavaScript. Just say no to JavaScript? Oh my gosh, Nick Hodges, that's crazy. Let's go to the exorcism. So it said Obama meme originated from 2008 Bush interview. I gotta stop. I probably should just do something different. Let's see what it means by this. So it said a fun question. Obama refers to Barack Obama, 44th president, while Oluma was a joke tweet by Stephen Colbert in 2008 pretending that John McCain's running mate Sarah Palin had mispronounced the name of then Senator and presidential candidate Joseph Cow. Is this all made up? Why does this sound made up? Does it just, I guess it just doesn't know what Olama is and it made up something wild. Or maybe it's true, I don't know. Maybe it's true. Okay, so on 48 and 24, we just have 2 more to do, and I'm gonna go for JavaScript. So, have I copied and downloaded this one yet? Let's see. I'm not sure. Alright, let's see. So let me paste this. Let's see what I get here. Okay, so we copied and downloaded that. Okay, so if we go in here and try and do Zebra Puzzle JS, so let's see what's in the stub, if anything. Oh, okay. So let's, oh, it's a class apparently. So we're going to have a constructor and water drinker and zebra owner. Okay, fair enough. And let's see how that's going to, oh, let's npmi. npmi, get this guy going. Always got to npmi with JavaScript. I think it's my least favorite aspect of JavaScript is always having to npmi. And it's not really necessary, it's just common. Anyway, so let's go to the spec. So it says what we're going to do is we're going to instantiate it like this. And then we are going to we're going to expect these answers, right? So, I mean, it's a simple test. Oh, here, one of them's disabled. Let's just enable it. There's no point in having it disabled, I don't think. Okay. Yeah, so technically, this would be one of the easier ones to cheat, and also one of the more disappointing ones to cheat, because it's actually kind of a cool problem, right? So let's take a look at the README. Okay, so the README has the 15 rules that we have to adhere to, right? So let's copy those rules into our JavaScript file. Yeah? Okay, so let's go into here. Okay. so now, I guess let's comment those out. And then, so I'm pretty sure I really just need the rules themselves, right? I already did it in Prolog, but this is going to be very different from Prolog because Prolog is a very interesting programming language that is perfect for this kind of thing because it did basically all the work under the hood. It was incredible. Incredible. Okay, so we just want these rules. Okay. So I guess maybe what we'll do is just solve in the constructor, maybe? So let's create our solve method, I guess. So it'll be called solve. And it's going to take in houses, I guess, which by default will be just the 5 houses, right? Like that. So that's something that will have to be passed in. But then we are also going to have a set of things that we are going to kind of like deal with, which are the things that have to be assigned to houses. So that's going to be, I'm going to say traits, maybe, characteristics. I don't know. Let's just say traits for now. And that's going to be a list of things, right? And so it's going to be English. Let's see. So in the spec again, it says it comes back as Norwegian or Japanese. Okay, so I'm going to say English, Norwegian, Japanese, Spanish, what's the 5th one? Ukrainian. All right. And there's a whole bunch of these, right? So I'll put those ones on all on the same line because those are related, right? And then we're gonna have like pets, so there will be a dog, there will be a zebra, there will be a snail, a horse, there will be a what's the, I think there should be one more, right? A fox. Okay, so now here we are going to have, oh, wait a minute. I guess I'd better say, like, what they actually are, huh? Sure. That's probably okay. I don't know. Making it up as I go along, I suppose. I think it's fine. So then there's going to be colors. So color, ivory, color, red, color, green, color, let's see, blue, and what's the 5th color? I got red. Are all 5 colors here? I see red, green, ivory, yellow. Oh, I didn't put yellow down yet. Color, yellow. Okay, sure. And then what other traits? There's going to be like a hobby, right? Hobby chess, hobby painting, hobby football, hobby dancing, right? Dancing, yeah, there we are. What's the fifth hobby? Hobby. I see chess, oh, reading. Okay. And then there should be 5 beverages, right? So drink. And it's going to be coffee. Drink. OJ. I'll call it orange. Drink. Was tea one of them? Tea. Drink. Milk. Is that 4? Do we have a 5th one? Drink. I've got coffee. I've got milk. I've got orange. Tea. The 5th one might not be shown. Let's see. So in the prologue solution, I had coffee, I had tea, I had orange, I had milk. I don't think the 5th one... Oh, no, the 5th one is water. That was... Okay, yeah, that's given. Water. There we go. Yes. Okay, cool. All right, so that's all of the traits, right? Okay, so if we look at this, this should be length 25, I believe, right? So I'm just going to go to my handy-dandy REPL. And I'm going to put this unexpected string. Oh. Okay, so 25. So that's everything. That's everything. All right, so I'm going to have those. But actually, I think what I want to do is I want to shuffle those, actually. So in the constructor, I'm going to say const, and then I'm going to do this. Okay, so let's prettier what we've got so far. Syntax error. Oh, okay, so this one will take traits. Okay, so there's what it looks like. So there's our traits. So now I want to try and shuffle these. So let me put a shuffle down here, I guess. So shuffle A equals 4 int I equals 0, I less than a length, I plus plus, j equals math random times, let's see here, this will be math floor times a length subtract I, right? Yeah. Plus I Is that right? J, if I do that, then J could come out as the same thing as I. I think that's okay. And then, let's see, swap A, I, J. Temp equals A sub I equals A sub J equals temp. Swap AIJ. Is that a good shuffle? I always look this up because I remember messing up the shuffle. Actually, it's been a while since I've looked it up. I don't recall the name of it off the top of my head. Oh yeah, Fisher Yates. Yeah, it's been a while since I looked that up. Pick a random number k between 1 and the number of unstruck numbers remaining inclusive. Should I do it like they did? Let I... Why is it going down? I think it's okay. I think it's okay. I used to look that one up every time because I remembered messing it up. Maybe I've messed it up this time. I think it's okay. I less than a dot length. Oh, I put an int in there that doesn't belong. I'm getting more messed up than ever, baby. Okay, good now. Alright. So, I guess that should be okay. So I haven't gotten into any of the meat of this at all yet, right? But basically what I'm gonna do is I'm gonna put, this... Should I use this in the constructor? I don't usually use constructors in JavaScript. I think it's fine. I think we're gonna say this dot solution equals solve shuffle traits. Okay. Okay, so now we need two basic important parts. So let me put some notes. There are two important things needed. One, a method to check whether a given configuration of houses is in violation of the 15 inviolable rules, which we have been given as part of the problem statement. Two, a depth first search which immediately backtracks whenever the past in configuration is found to be in violation. Okay, so that's basically the idea of what we're doing, right? So solve is going to be the backtracking. Solve is going to be the depth first search method. Recursive. All right. So I hope that's starting to sort of make sense now. I started jumping in with a bunch of weird stuff without saying what I was thinking, but this is basically what I'm thinking, right? So now we want a method for is in violation. All right. And it takes houses. So I guess it should be are in violation. I'm just going to say in violation. And it takes houses. Okay. So now this is kind of the important one where all the rules go, right? So let's grab these rules and put them in here. Okay. So this is going to be, I guess it's just going to be a return houses length not equal 5. Or, so that's this one, right? Houses length not equal 5. Okay. Or, Englishman lives in the red house. So this is going to be houses dot any sum house nationality equals English and house color equals red. Yeah? Or, oh, wait. We're checking for in violation. So, for it to be a violation, both of these have to be defined. So it's either, okay. So house.nationality equals English, and house.color, and house.color not equal red. Okay. Or house color equals red and house nationality not equal, not equal English. All right. Okay, so what's prettier say now? Expected comma. Okay. Cool. So, so there is some house where the nationality equals English and the color is defined. and the color is not red. Or this, but there's another case, which is if there is a house that is English and a different house that is red, then that's another violation, right? Oh, shoot. Okay, so or houses find. Okay, so then when we do find, it just comes back undefined, right? So really, this should be its own method. Let's make each rule its own method. Let's see here. For convenience, let's make each rule its own method. Okay. Rule 1. Houses. Return, let's just say, houses length, sorry, not equal 5. Rule 2. Houses. Okay, yeah. Rule 2 houses is going to be this, and then we're going to finish it by saying what? If is that not going to work? For some reason, I thought that was allowed. You can do it sort of like that in C#. If it's not allowed, that's fine. On 80. And then English house equals houses find house nationality. Let's do this. Nationality equals English. Yeah. And then red house equals houses, find color. Color equals red. And then if red house and English house return red house not equal English house, return false. Expected. Oh, yep, that's right. So return rule 1 houses, or rule 2 houses. Okay, so then let's go to rule 3. Okay, so rule 1 goes up here. Rule 2 goes here, I guess. Solve is not defined. I'm trying to define it down here. Can we not access it in the constructor? Oh wait, where did I try to define it? Oh. Is that possible? Okay. Houses is assigned a value but never used. Okay, we'll get there. Traits is declared, but its value is never read. I tend to avoid this sort of object-oriented type boilerplate when I use JavaScript. It already is looking like a big file. I've only done 2 rules. How ridiculous. Okay. Well, let's go to rule 3. Okay, so now, I can see that these are similar already, right? So in the prologue, and this solution is quite short. In the prologue, I used house exists to be like, oh, there is some house that is like this, right? And that was used for rule 2 and 3 and 4 and 5, right? So it's going to be similar here. We're going to reuse some rule. So this is going to be called rule house exists houses, and it's going to take a K1 V1 K2 V2, I guess. and then it's going to be basically just this, right? And now, instead of saying this, instead of saying dot nationality, we are going to say K1, right? And I don't think we can do it quite that way here. So this is going to be called, let's see, English house, house 1. Okay, so then this is not going to be like this. This is going to be house, and this is going to be house sub K1, and then this is going to be, wait. This is going to be V1, right? So that's going to be here as well, and here, right? Okay. So then color will be sub K2. This will be V2. Okay. And then red house, let's make that into house 2. All right, so rule house exists. Houses K1, V1, K2, V2. So if house is some house, house K1 equals V1, and house K2, and house K2 not equal V2, or house K2 equals V2, and house K1 and house K1 not equal V1, then return true. And then house 1 would be whatever house has K1 equal V1. House 2 would be whatever house has K2 equal V2. And then if those both exist, then return they are not the same. And then if we get past that, we say false, not in violation. So then rule 2 becomes, return rule house exists, right? And we put the houses in, and we put nationality, English, and we put color, red. Okay, that's fine. So that means rule 3 now becomes relatively simple-ish, because we just return rule house exists, houses, and then this one is nationality again. This one is Spanish. This one is pet. And this one is dog. Okay. So now we are going to copy, let me prettier again. We are going to copy this, because we have several more that are going to be like this, right? So rule 4 is going to be like this. Rule 5 is going to be like this. Rule 6 is a bit different, but Rule 7 is going to be like this. Rule 8 is another one like this. Rule 9 is a little different. Rule 10 is a little different. Rule 11 is a little different. Rule 12 is a little different. Rule 13 is one just like this. And 14 as well. Okay. Oh gosh. I think I just did something. All right. So rule 4. Okay. So, oh, interesting. So it formatted those in a way that I wouldn't necessarily have done. I think that's kind of bad for clarity personally, but I'll just go with it. It's prettier, whatever. Okay, so then we're gonna say color, green, drink. Why does it say recording? Coffee. Okay, so then this one is Ukrainian. Drink. Tea. This one is pet. Snail. Hobby. Dancing. Okay. This one is color. Yellow. Hobby. Painting. All right. This one is hobby. Football. Drink. Orange. I guess. Okay, sure. And then this one is nationality. Japanese. Hobby. Chess. Okay. So let's leave that alone for a second. Okay, now let's look here again. So yeah, so that was rules 2 through 5 and 7 and 8 and 13 and 14, right? And then here at the end we said, oh, there's a zebra. Okay. So then we have another one where we want to look for a particular position of a house. So those ones are actually a bit simpler. When I was first looking at those ones in Prologue, I didn't think they were simpler, but they are. So rule 6 Rule 6, let's come back to. The simpler ones are rules 9 and 10. Houses. Okay. So, the middle house, right? So here we just say house is sub 2, right? And then we'll say drink and house is sub 2 drink not equal milk, right? Well, I guess we would say const milk house equals houses find drink equals milk. And then we would say milk house. So if we found one and it is not the middle house, or, right? Okay, so two cases. So we were going to look for the house where the drink is milk, and we're going to be like, okay, so in this case, oh look, I found one, but it's not the middle house. That's a violation. Or I found that there is a drink at the middle house, but it is not milk, then that's a violation, right? Okay. So, man, it was a lot more elegant to write it out in Prolog, wasn't it? I just did it like this. Part of it is because in Prolog, these are like writing out the matching rules and not the violation rules. And I could probably do that in JavaScript as well, but as I thought about it yesterday, I thought it would make more sense to write the violation rules because of what I wrote here, right? Do I still have my comment? A depth-first search which immediately backtracks whenever the passed-in configuration is found to be in violation of the rules, right? So that's why I'm looking for violations and not for matches. And I think it just makes more sense to me, so I'm going to go for it this way. But it is harder to write the violations than the matches. Or at least just, there's more to write, there's more to it. Alright, 10 houses. So 10 is the Norwegian lives in the first house. Okay, so I'm going to say Norwegian house equals houses find nationality. Nationality is Norwegian. All right. And then I'm going to say return Norwegian house and not equal houses sub 0. All right. Or houses sub 1 or sub 0 nationality and houses sub 0 nationality not equal Norwegian. So that's obviously pretty copy-pasty from the one above. I'm going to leave it alone, though, because those are the only two that are like that, I believe, right? It's just these two. If it were 3, I guess I would extract it to a reusable method, but as it is, I'm going to leave it alone. So then let's see which rules are remaining. Okay, so we did this one. Let's move this up. And then I have rule 6, 11, 12, and 15. So if I review what I did here again, for 6, I used something called adjacent houses, where I have a left and a right house. And then for 11, 12, and 14, I used something called, or for 15 rather, I used something called houses next to, where I said, okay, so either this one's on the left or that one's on the left, but either way, they are adjacent. So, let's make this a thing. This one's gonna be a little more complicated. Man, I've already been at it a while too. My goodness, I'm not even to the good stuff. All right, so rule 6, the greenhouse is immediately to the right of the ivory house. So let me put a rule 6 in here. All right, so we're gonna say, let me put it up here somewhere. So rule house exists. Let's move rule 1 down by rule 2. Okay, so then this one is going to be rule houses adjacent. Houses. And then the other thing is, so I had this one, I had 2 different colors. So we need a left key and value and a right key and value. And in the case of next to, it's just key 1, value 1, key 2, value 2. Yeah, okay. So I'm going to say left key, right key, or no. Left key, left value, right key, right value. All right, sure. And then I'm going to say left house equals houses find house So here, since we are looking at the locations, I guess it had better be find index. All right, so then this is going to be house left key equals left value. And then const right house index, houses find index, house right key equals house, excuse me, equals right value. Yes, okay, something like that. All right, cool. So when we do find index, it comes back -1 if it's not in there, right? So if left house index not equal -1 and right house index not equal -1, return right house index subtract left house index not equal -1. Okay. So that's if they were both found. All right. So now if one of them or the other was found, then we have to check that the wrong thing isn't in there. Okay. So if left house index not equal -1, also, okay, so let's check that they're not in a bad place. So if left house index equals 4, return true. If right house index equals 0, return true. If left house index not equal -1, return houses sub left house index +1 sub right key. So here we just want to say that it's not defined, right? And that's in violation. Now, another thing that we could note here is that, like, if we have found a left house index here, then we would do well to just fill in the right house index, or just fill in the value, excuse me, just fill in the value at this point for the one on the right. But that's not going to be part of checking for the violation. That's going to be something that would be a good tweak to include later. This is going to turn super long. This is already such a big file. It's crazy, actually. Wow. Okay. So, yeah, let's come back up here. So, if right house index not equal -1, return not houses, wait a minute. Okay, right house index subtract 1, left key. Okay, so then after we've checked all of those, we want to return false, because we've determined that it's not in violation. So this is kind of sad because I'm actually not even going to use this again. In the prologue version, I used this again here, but I don't think I'm going to do anything like that this time. I think I'm just going to use it for Rule 6. Oh well. So this will be return rule houses adjacent, and it's going to be houses. This will be color. No. Oh yeah, they're both color. The one on the left is ivory, and this is color as well, and the one on the right is blue. Okay. So that leaves rules 11, 12, and 15, which are all about next to, right? So this will be rule houses next to houses key 1, value 1, key to value 2. All right. So const house index 1 equals houses find index house key 1 equals value 1. Go. And then this one is house index 2. This is key 2, and this is value 2. Okay. So if house index 1 not equal -1 and house index 2 not equal -1, return math.abs house index 1 subtract house index 2 not equal 1. Okay. So then, let's see. So then we don't have something like this. They could be wherever. So let's go if left house index not equal -1, return not, wait a minute. Hey, look at this. I did this wrong, didn't I? I think. So if we found a left house, here, let me put a comment here. Oh gosh. Let me put a comment here. If we found the left house, but not the right, then we should expect no value for the house directly to the right of the left house. Okay, so is that what we said here? So we found the left house, but not the right, because if we had found both, we would have returned here. See, this is where I messed up because I'm looking for a violation. So let's say it is a violation if the house directly to the right has a value, right? So this should be double banked. And this as well, right? So now we're saying, okay, so we found something on the left, and now we're saying, okay, if there is a value here, then that is a violation. And if there is a value here, that is a violation. Okay, so I had messed that up. And honestly, it gets a little convoluted even in my mind. Even in my mind, it gets a little convoluted because, like, logically, I feel like I need to be looking for violations because a violation is gonna a violation is what is going to trigger the immediate backtrack. So for that reason, I feel like it's got to be looking for a violation. But I'm gonna need to look over these again. So rule 1, okay, so if the house length is wrong, then that's a violation. Okay. So then the rule house exists. I'm glad that this one is in its own reusable function because this might need some debugging. But basically, we're going to say, okay, so there is some house that has the correct value here, but some other value here, so that's a violation. Then if we find that there are two different houses with that defined, then that's a violation. Yeah. So I think that part seems solid. I think on the adjacent houses, it's a little trickier. So let's see. So if the left house is on the far right, that's a violation. If the right house is on the far left, that's a violation. If we found indexes for both, then... Uh-oh. Why do I have -1 here? Oh my gosh. Okay, I'm glad I read over that again. Yeah, the right subtract the left is supposed to be 1. If it's not 1, then that is a violation. The -1, I don't know, that came out of nowhere. And then these had been wrong. We're saying it's a violation if it has something defined that is not the right thing. Okay, so next two is going to be similar. So we looked for both house indexes, and we're like, okay, so if they're not next to each other, then that's a violation. All right, so now if we found this one, then it is a violation if both houses next to it are in violation. So there are a couple cases here. Wait a minute, this is not left house index, my goodness. This is house index 1. So here we return house index 1 greater than 0. House index 1 greater than 0. Let's say equals 0, or houses sub house index 1 minus 1 key 2. Okay, so this one could be a violation. If we're already on the far left, then there's no chance for a house to be next to us over there. Or if there is a house next to us there, but it has something else defined. But it's got to be both parts, because if this other part is not true, then it's not a violation. So this is going to be house index 1 equals 0, or double bang, houses, house index... Oh, why do I have a 0? I put 0. 4, there we go. Plus 1, key 2. And that's it. All right. It says use Boolean. Okay. Interesting. I had no idea that using double bang had ever been looked down upon. Maybe it is kind of like a weird thing, though. Okay. I guess I'm okay with that. Yeah, I feel like Boolean, or using the double bang for Boolean was just one of those things that we were just accustomed to. All right, so this is what I did. So then the next one is going to be, we're just going to change it, house index 2. All right. And then these become a key 1. Yeah? All right. That's kind of ugly. So I'm going to use this 3 times once for each of the remaining rules. So let's put in a rule 15, houses, return this dot rule houses next to, and we'll put in the houses. Key 1 is going to be, grab it. So this is going to be nationality, Norwegian, color, blue. Yep. All right, then rule 12 is going to be similar. Okay, so for 12, it is hobby, painting, pet, horse. Okay. And lastly, rule 11, houses, return this dot rule houses next to. Okay. So this is going to be hobby, reading, pet, box. Okay. Well, okay, so then when we do in violation, it's going to be or rule 3. Or rule 4. Six, or 7, nope, 7, or 8, 9, 10, nope, where's root 10? Or 11, 12, 13, 14, 15. Okay, so that's what we've got. So, yeah, so if we have any violation amongst any of these, then that's the violation. And I want to say, having looked over these, I think that these are done correctly. I'll find out at some point soon-ish. if there are bugs here, but my goodness, that is so much. So, that is supposedly the method to check whether a given configuration of houses is in violation of the 15 inviolable rules which we have been given as part of the problem statement. And for convenience, quote unquote convenience, oh my goodness. So yes, I put each rule into its own method. Great. Okay. Now we want a depth first search which immediately backtracks whenever the passed-in configuration is found to be in violation of the rules. All right? So, I have some traits. I decided to shuffle them, which is not necessary, but I figured it'd just be just fun, I guess. I don't know. Not fun, but I don't know. If they're shuffled, then I feel like... Now, if I messed up the shuffle, then that's going to mess up the whole thing. I think it's okay, probably. Here, let's go find the shuffle, and let me check if it seems to be working. So here's what I've got. All right, so the shuffle is here. Let's put this into my REPL. I haven't been on here in a while. So I'm going to say function and function. All right, so now shuffle. A, B, C, D, E, F, G, H, I, J, N, O, P. So do those look shuffled? I mean, I think so. I've got A, B, C, D. Where's D? Uh-oh. Oh, there's D, E, F, G, H, I, J, K, L, M. Where's N? If I lost any of them, then it's not working. N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So they do appear to be shuffled. I gave it one test run. I think it works. Whatever. All right. Okay, so now we're going to go to the depth first search. So solve is going to be the depth first search method recursive, right? So let me put this up here as like a heading. And then let's just do this. Let's just do this solve. Okay, so we get traits in and we get houses in. So the first thing we need to say is if in violation houses return. All right. Okay, so if it's in violation, we just stop, we don't do anything, we return nothing, and that's it, right? Okay. Now we need to also be able to check whether they're all filled in. So let's see. So we just checked if they're in violation. If they are all filled in, then we need to pass them back. So I'm going to say if, okay, so if I have houses, and I go let's see, houses, map, object keys map length. What if, how about reduce ac e ac plus. What if I do that, and then if I say we've filled 25 in, then we're done? I don't know. I think it's probably good enough. So I'll say if houses map object keys reduce ac e ac plus e length 0, right? And then say equals 25, return houses. Okay, so those are our two base cases, right? Let me make the note. First, we define the backtracking base case. This branch is not promising. Okay? If it's in violation, then it's not promising. And then here we say, second, we define the success base case. All traits filled in. And that's here. Okay. So great. So now, whichever trait that we have, we're going to say, here, let's say, if I have this traits sub-0 match like this, and I say const kv equals k. Yeah, let's do it like that. Let me just copy this. And then I could also do this by saying something I noticed, the REPL doesn't bug you if you reuse const anymore, and I think that's good. I wonder if it's a setting that you can change, but like it used to be, if I tried to do this again in the REPL, it would say, oh, hey, don't. And now it doesn't bother me about it anymore, and I think it's a big improvement. So anyway, what if we just say pop here? So now I have kv, and now traits are like that. I don't think I can mutate the traits when they're passed in. I think that's gonna mess me up. I think I need to copy them and not mutate them. So if I were to say slice, now K and V are drink milk, but traits still has drink milk there because we didn't mutate it. So I'm gonna say const traits tail, or I'm just going to say copy, equals trait slice. I always use that slice for making a copy. I don't know. There might very well be a better way now. Array slice. Or maybe there was a better way all along. I don't know. Do they have copy? They have copy within. Shallow copies part of this array to another location in the same array. So that's not really what I want. I think just using slice is what we typically do to get a copy. Returns a shallow copy of a portion of an array. The original array will not be modified. So that's typically what I do. I typically just call slice with no arguments. All right. So then I will say const kv equals traits copy pop dot match, right? And we're gonna match on whatever character is not a colon. Not a colon, there we go. However many times we see that. And that's gonna be group 1. And then a literal colon. And then group 2 is just anything that comes after that. Okay, like that, right? And in the REPL, is that how I did it? Let's just copy this and see if I redid the same exact thing as I did before. Kind of checking myself just a little bit. I treat regexes with respect. This is quite a simple one, but I try to treat them with some respect and kind of check myself. But yeah, there we go. Underscore is assigned a value but never used. So yeah, that's supposed to be an anonymous. I don't intend to use that at all. That's a throwaway. That's why I used a single underscore. Hopefully it doesn't bug me about that too much. Anyway, let's see. So we did this. Okay, so now we are going to... Now we are ready for the recursive calls. So we're going to return, and then this is going to be it's going to be 5 different versions of the houses, right? So I think I will say new array 5 fill map and it's going to be houses, and I'll make a copy of houses as well. That's maybe not, yeah, that's probably necessary. We need to make a copy, I believe. And then we will map that house J. And so then it's going to be I equals J. Then it's going to be house KV, I believe. I'm going to check this on the REPL, but I think it's basically like this. Else house. So then once we have those 5, we are going to find And here's the recursive call. Okay. All right, so now, are there complaints in there? It doesn't look like it for now, so I think we're good-ish. This is so long. Oh my goodness gracious. But the nice thing is the recursive call itself is not huge, right? Like, this is where the action is happening, in my opinion. Okay, so now let's try this out at the REPL and see if it does what I think it's supposed to do. Oh, now it's complaining. Or no, maybe not. Okay, let me find that. Make sure this is doing what I think it's doing. Okay, so I got drink milk at 0. I got it at 1. I got it at 2. I got it at 3. And I got it at 4. So I'm going to take a short break. I believe that what I've got so far should be enough to solve it. So let me take like maybe 10 minutes to look this over carefully, because I'm a little scared. So then here it'll be return this solution, find drink equals water nationality, right? And very similar here. So this will be pet zebra, right? Okay. I'm going to run the test. Okay. Solve is not defined. Okay. Cannot read properties of undefined reading match. Oh, interesting. So, and it says the same here. So, that's not what I hoped to find. So if we got to that point and there was nothing left on the traits, then the expectation was that we should have returned the houses here. If there are no traits remaining, that should likewise mean we're done. So something went wrong here. I thought that if we had all the traits gone, that we should have, I guess, hit this, but maybe not. So there's a bug for sure. And I'll try and address it, but but actually I don't quite know how to try to address it just yet. Okay, so I think it's slow as heck, or is it? Oh, okay, so we didn't find anything. So there are likely some bugs and things. So let's go console log JSON stringify this solution. Honestly, it is probably undefined. Maybe? No? Well, what did it say? It said, cannot read properties of undefined. So if the solution was undefined, it would have said reading find. So something's happening. I'm not sure what yet, but we'll see it when we console log. Okay, so it looks like only one thing got filled in. Darn. That's dumb. And it took forever. It took like 4 seconds. That's crazy. So I was expecting it to be faster than 4 seconds. It should be. So there are multiple problems here. All right. I think it's this, right? So we tried to take a slice of the houses. Oh, wait a minute. That's a shallow copy. So we don't need to do a deep copy on the traits, but I think we do when it comes to the houses, or at least, well, we'll see. So that's not any better. For some reason, it ran a lot faster, like a lot faster. What's the deal there? Is it because of the shuffling? Okay, I think this is wrong. I think this should be map. Yeah, I think map should be okay there. And then, well, I wanted find because find will stop as soon as it finds something. But the problem is it's going to give back the copy, or it's going to give back what's here instead of what was found here. So let me just see if there's another method that I should use instead of find. But if I just have to use, like, it looks like I'm just going to have to use map, and that's probably okay. I don't know. It's going to be slow, though. Are we able to see any output? Okay. So is this exporting? Export? So let's see if I can import that in Node. Unexpected token export. You know, it's just so much easier to use the module exports and the require. At least it always has been for me. And so I haven't used to learn the, excuse me, I haven't learned to use the import export properly. I use it if I'm using Webpack or TS compile or whatever. Anyway. Okay. So that's close. Now, where do we need to try to print? Okay, so a lot of things happened. Um, so let's just take one of these and put it into my REPL, and I'm gonna take like a 5-minute break here soon. Okay, so this is what it ended up looking like here. So I had a drink, a hobby, a pet, a nationality, Norwegian. Hmm. I guess I don't really get why, when it was find and not map, it actually seemed to be stopping faster, like by a lot. Um, so I can't use find then. I'm gonna have to just use a loop. That's fine. It's just gonna have to be a loop. That's totally cool. Oh, interesting. Pop match, not a function. So back to that again. That's a little crazy. I did not expect that at all. I've messed something up. I need to take a 5-minute break. Okay, let me go ahead and just come back in 5 minutes then. All right. Well, I don't know if I'm close or not. It's getting a little exciting. So I've screwed something up, right? Because, well, I've probably screwed many things up. We'll see how many. Uh, this was not expected to happen. Like, this should have been okay, like, all the time, pretty much, right? So, let's go in there and see what's happening. Okay. So, I'm gonna say next trait equals traits copy pop. Okay. Next trait match equals, and I'm gonna put this next trait. Okay. So then this is gonna be next trait match. But first we want to say if not next trait match console log traits copy next trait match. Okay. If not next trait console log traits copy next trait. Well, it's supposed to be a string. If type of next trait not equals string, oh, I've made some absurd mistake here somewhere. Okay, so where are we calling solve? Okay, so I put the traits in. That should be okay. Yep, I see it. Oh my gosh, that's insane. That is completely insane. Ha! Okay, well, let's see what it does now. Something wild. Oh, I got a wrong answer. Okay, fair enough. That's not good. Apparently it got a correct answer on water, but is that just by chance? No, it passed water again. What's going on there? What is going on there? Okay. Um, okay, so let me find the consoles. Water does keep passing. So that's actually super weird. So it's kind of working, and it is running in under a second, so that's good too. Oh, except not this time. It depends on how they're shuffled. That time it took way long. Holy Moses. Holy Moses. Wait a minute. Okay, so there could be some crazy things happening. So, do the tests not necessarily run in the same order every time? Oh, interesting. So they both get newed up each time. Water drinker Norwegian. That's crazy. Okay. I think it doesn't really make sense. I think water keeps passing probably mostly by chance. Not sure yet. We'll see. So, I've got these traits. It's not coming up with the zebra correctly. Zebra owner, return this solution find. Oh, wait. Is it coming up with the same thing every time? It is coming up with undefined. Oh, it came up undefined this time. This was Norwegian. This was undefined. Oh, wow. And this was Norwegian. Oh, my goodness. Okay, so it's a little crazy. It's a little crazy. It's not correct. That's for sure. Okay, so another thing. So I think in violation probably isn't quite right yet. That's where the bulk of the code is here, right? So it's weird that water keeps passing though. It's actually really weird that water keeps passing, and I wonder it's got to be just by chance. Do we have a better way to copy? Like this is a little slow. I'd like to just have a better copy. JavaScript array deep copy. Yes, MDN. That's the only one I want. So we can use JSON, but yeah, so that's what I did. It's a little slow. Let me just look real quick. So A equals A. B equals. So A equals B should be false, but they are both copies, right? So let's do that. Copying an array of objects where each object is a simple string. Dict is in the form of a simple string dict. Basically, yeah, so return a map I think that should be faster than parse stringify. I believe. I want to say probably. I don't know. But that's not where the main problem is. So when we do this, let's go ahead and console log this, or JSON stringify this solution. Okay, so here are the solutions I got. So I think that what I'm going to find is that there is a violation of some rule, probably. All right, so Norwegian in the first house. Okay, cool. Okay, so first of all, let me check. I'm so weirded out that water keeps passing. That is crazy to me. Because, I mean, it just illustrates that I don't understand the problem. So I am going to try to copy all of this code here for the violation. In fact, let me try just copying the whole thing. All right, let me try pasting that in my REPL. And so now if I say A equals new zebra puzzle, so A in violation, A solution. So it says it's not in violation. Hey, look. This is not complete, though. It's not even finished. Right? Wait a minute. Wait a minute. I do see what I did wrong, actually. I made a very simple, obvious mistake that I didn't see till right now. So this will if the key is already defined here, then this will clobber it. So that is actually not acceptable. Okay, yeah, that's a very simple, obvious error. So these are the copies. Const candidate copies equals copies filter. And we're filtering on copied houses, right? copied houses sub I, and so then this is going to be not sub K, right? Const candidate configs equals candidate copy. Wait a minute, wait a minute. Okay, I'm gonna go back. Okay, so when we do this, we are gonna say house sub K and if that is defined, then we're gonna say null. Otherwise, we'll do this, all right? Filter. Is that it? Okay, now let me put this into the REPL and see what sort of results we're getting. Actually, well, hold on. Let me just run the test first, because that should make a difference. Okay, cool. Yeah, it does make a difference. Cannot read properties of null. Okay, so I wasn't supposed to pass null. Okay, so I've got 2 passed. So let me get rid of the console logs. Okay, so I've got 2 passed, and these times I think are reasonable-ish. They're not great by any means, but reasonable-ish. Okay, I'm gonna submit. That really is an interesting one. I just submitted a ton of code on that one. So making it shorter, I think, would be good. I'm gonna mark it as complete. And making it run faster, I think, would be very good because it's the runtime efficiency, like 385, that's not good. It's okay. Um, okay, so I'm just gonna look over this and see if there are things I want to change. So we've got these different traits. Um, okay, so solve is the depth first search method, recursive. First, we define the backtracking base case. This branch is not promising. In violation, we define the success base case, all traits filled in. Okay, now, this should not be necessary now, I believe. Yeah, these times are still just barely on the cusp of okay. I'm glad that none of them are over 500 milliseconds. Okay. So, that's good. Okay, now using this regex all the time, that's unnecessarily inefficient, I think, right? Probably. I feel like it's got to be a little inefficient, right? So in reality, these traits should probably just be redone. All right, just like this. All right, and then wherever we have this colon, and then at the end here, put this. Oh, shoot. Okay, and then let's get rid of that regex. That's, yeah, that was silly the whole time. Okay, seems okay. Now, so we do see that a couple places. That's okay then. Okay, now what about this? So we're saying new array, fill. I feel like I don't even want to do that. I think I would rather just say... Since we know it's 5, 5 is pretty small. What if we just do that instead? Oh, shoot. That one actually took over a full second. That's really bad. Okay, so swap doesn't necessarily have to even be like that. We can just say I saw, where did I see it? I saw it on Wikipedia, right? They just went what did they do? They said, you know what? I'm just gonna leave it. It's not a big deal, I don't think. I don't like seeing these mashed together so much. Yeah, I'm seeing some pretty bad run times. If I'm being honest, at this point, I think that to get better run times, I would probably have to go to a different approach. And I'm not prepared to try to do that today. I actually, like, I mean, I like this approach. It's, you know, in theory, this approach is kind of straightforward. It's just, it's crazy that it took me 2 hours to do it. Talk about, like, I don't know, skill issues. Okay, I'm gonna submit again, and then I'm gonna take another short break. I'm just gonna go outside for a sec to, I don't know, clear my thoughts or whatever. And then I'm gonna come back and tackle the Scala, because the Scala is it. And then look. Seven more hours until the new year hits in Christmas. I think this is from the English word Christmas, but it's spelled in like the local spelling style. Anyway, so the place is called Christmas Island, and that's the first place that they have the new year, right? Anyway, there are 7 hours left, and I want to hit it before that, but it's not going to take me 7 hours to do the Scala. It better not. So yeah, it just is such a huge amount of code in here, just really crazy. And it's not even really that efficient. The efficiency could be worse, for sure, but it's really just okay, unfortunately. Like Prolog solves it consistently very fast, you know? Anyway, I'm gonna take 5 minutes again and come back, and then the next one is going to be Scala. Let me just bring it up real quick. It's the last one on the whole list. Zebra Puzzle Scala. Alright, so this is gonna be it. Oh, it's listed as a hard. Wait, was it listed as a hard on JavaScript? Hold on, let me look. Zebra Puzzle. So I finished it in JavaScript, I finished it in Prolog. I had opened it in Python but didn't finish it. And then we're going to do it in Scala. Yeah, it's listed as a medium in JavaScript, and it's listed as an easy in Prolog, and it was easy once I knew a little Prolog. It's listed as a medium in Python. It's listed as a hard in Scala. Well, now I'm a little scared. I think that the approach that I used should transfer well to most programming languages, and I would think that that would include Scala. So the way I did it in JavaScript honestly was kind of hard for me. I don't think it should have been that hard, but it was. But I think that if I just copy the JavaScript, I think I'll be able to knock out the Scala in less than 3 hours. I don't know how long it'll take. I think it'll be less than 3 hours. Hopefully a lot less. But that's my prediction. All right, let me come back in 5 minutes. Yeah, 5 minutes, 5 minutes. Okay, I'm back. I gotta say, I gotta say, this for me, this zebra puzzle is honestly a pretty big, by my standards, this is a fairly big puzzle, right? Like it's kind of like a relatively, I don't know, complex backtracking problem, I guess, and I'm giving myself a pat on the back for having finished it. Let's go to the Scala one. And this is the very last one. This is number 144. All right? So if we look at this, I have completed 143 assignments, and we are on the last one. Scala zebra puzzle. Marked as a hard for whatever reason. I don't know what makes it harder in Scala. I hope I don't find out the hard way. Let's see. So we're gonna go to Scala zebra puzzle. Okay, so let's take a look at our... I'm gonna just look at everything. Help. So it should be pretty simple. We run SBT test. Let's see what happens. Illegal reflective access operation has occurred. Okay, so did it actually... Oh, an implementation is missing. Okay, that seems fine. Anything else? Let's see. Pending. Okay. Let's look at the README. Alright, so... I don't think there's anything that I haven't seen already. I think this is just great. Here's the guy from the video. He seems very sharp, too. I really liked the way he presented in the video. So, oh gosh. Let's not look at all that. Let's see. So we've got our source. Let's just go into the source. Let me look at the test first. Let's bat that one. Okay, so there's not a lot in here. It just says, should be water drinker, Norwegian, zebra owner, Japanese. Fair enough, fair enough. Okay, let's go into the source file. Okay, so here's our stub. I have case object Englishman extends resident. Okay, fair enough, fair enough. I guess I might need to use things like that. It says it's a lazy val solve solution. Okay. So some of this might bite me in the butt or whatever, but we'll see. Let me copy my JavaScript solution into here. Hey, I like this track. This track has really grown on me. Okay, so now let's yeah, let's go in there. Okay, so here's what we had for the JavaScript solution, right? Okay. Oh, goodness. Lazy val solve solution equals, I don't know what. All right, fair enough. Sealed trait resident. So is this how we do an enum in Scala? Let's take a look. Scala enum. I think it's a little different, right? So we have a regular enum, right, with cases. This one also has cases, though. Sealed trait resident with 5 cases. So this one says, so enum color, case red, green, blue, defines a new sealed class color. Okay, so this is sealed, but it's a trait. 3 values, color red, color green, color blue. Okay. Parameterize, so we didn't do that. Okay, so I'm gonna say what we want to do first of all is go ahead and make some of this, like, sorry, I can't even speak. I'm like a mess now. Okay. So I want to say some of this is going to be copied. So I'm going to say sealed trait pet case object dog extends pet, right? And then this is going to be zebra, snail, horse, and fox. How's that? Okay. Sealed trait color. Sure. Case object ivory extends color. And then this one is red, green, blue, yellow, maybe something like that. Sealed trait hobby case object chess extends hobby, something like that. Painting football, whoops, football, dancing, reading, yeah, okay. And lastly, sealed trait drink case object coffee extends drink, right? Uh-oh. Recording or something. Okay, so what was it supposed to be? Orange, tea, milk, water, right? Okay, so sure. So I guess we kind of want that. I mean, it's not so different from a little bit of what I had in JavaScript, right? Except now I think I'm gonna need like a list of all these things, but it's okay. It's probably okay. It's probably okay. so now I guess if we want to define a house is going to be something that has one resident, one pet, one color, one hobby, and one drink. That said, any and all of these can be null or undefined or whatever, right? So do we want to do that? Like, okay, so case class solution. Okay, so lazy val solve is supposed to give back this solution, which is just a water drinker and a zebra owner. That seems fine. So I'm gonna say case class house is it just gonna be resident, resident, pet, pet, color, color, hobby, hobby, drink, drink? Is it just basically like that? So we want to be sure that these are nullable, right? So let's see. So Scala class. Let's look in the tour of Scala. Yeah, this looks nice. Okay, so they did something like this. So are these nullable? Let's see. Null. Scala, what is nullable? And what is explicit nulls? Explicit nulls. It's an opt-in feature that modifies the Scala type system, which makes reference types anything that extends any ref non-nullable. Okay, interesting. By the look of this, I would say we can probably just say null by default. So we'll see how that goes. All right. Okay, so I guess we've got traits kind of laid out. We'll probably man, I need to blow my nose. Hold on. Be right back. Okay. All right. All right. What are we thinking? Let's. Man, I've been sick for like more than a week. I think I'm on the mend. I think I may be starting to get on the mend. Let's see. AI. What is the best ice cream flavor? Okay. So, what are we doing here? It says, "Yay for music, music rocks, dude." Yeah, it's not a very good AI. All right, it's not a very good chatbot. So, when we go to solve, I guess we are going to need to go ahead and sort of create our solution or whatever, right? You know what this makes me think of? So in the JavaScript solution, I was shuffling the traits. What if I just hard code them to a value that seems to solve quickly, right? That's like a form of the cheating that was talked about in the video, right? So if I'm in here, and I'm going to shuffle these, and we console log JSON stringify shuffled, then we can run this a few times and see if we find one that seems to have a fast time-ish, and just use that. What if we were to do that? So here's 58. I think we can beat 58. There's a 28. 28 is good. There's a 29. Can we... Oh, here's a 22. Okay, I'm going to say 22 is good enough. So... yeah, if we hard code one of these... They were both logged at the same place. So I'm going to copy both of these real quick. Copy. I'm going to put them in here so I've got them. All right, so I think this one was the one that seemed relatively quick. Let's see. So copy that. Okay, so now if those are hard-coded like that, are they going to be fast all the time? I think so. Yeah. So the reason I thought of that is because I think it'll help me in Scala. If I'm using the same solution, then I think this same ordering of traits should be fast either way, if it's the same solution. But if there are differences in the implementation, then the order that's fast will probably also be different. I don't know. In any case, I'm going to go ahead and get rid of the shuffle. And I'm going to get rid of the swap. Okay, is there anything else I can get rid of? I don't think so. Okay, I'm going to resubmit that. And I mean, I don't think that that's like the fastest order by any means, but it seemed like a relatively fast one, I think. It wasn't, yeah, there was no intention to like exhaustively search for the fastest, but that is a pretty fast one, I think. So, let's see. Okay, back to the Scala. Gotta finish the Scala for sure. And I'm worried because for one thing I just don't know like hardly any Scala. But let's give it a shot. So source. Okay, so solve is supposed to return a solution, and I've got equals, and now something is supposed to happen here. So let's start with this rule house exists. Let's start with this. All right. So we're going to try to put this in here. All right. So I've got rule house exists. So this is supposed to return a bool, right? Should I put... Wait a minute. Okay, so lazy val solve. Let's look at Scala method definition. First look... All right, cool. Let's take a peek. So they did def double a int equals... Okay, cool. Didn't show the method's return type, but you can show it. Okay, sure. So I'm going to say def, all right, and now houses is going to be, I guess, a list of house. So let's look at Scala collections here. Oh, a new version, sure. Okay. This chapter introduces the most common Scala 3 collections and their accompanying methods. Scala comes with a wealth of collections types, but you can go a long way by starting with just a few of them and later using the others as needed. Similarly, each type has dozens of methods to make your life easier, but you can achieve a lot by starting with just a handful of them. Yeah, sounds good to me. Okay. Therefore, this section introduces and demonstrates the most common collection types and methods that you'll need to get started. All right. Okay, so we want to consider three main categories of collections. So this page demonstrates the common Scala 3 collections and their accompanying methods. I feel like I want to turn on some effects. I haven't been using effects much. I have the BRB screen. I used to use this all the time, the confetti on click. I'll give it another try. And I want to use, like, color cycle, I think. Color cycle. Okay, cool. So, let's see. Crack open another one of these. Okay, so looking at Scala collections from a high level, there are three main categories to choose from. Sequences are a sequential collection of elements and may be indexed like an array or linear like a linked list. Maps contain a collection of key value pairs like a Java map, a Java map, Python dictionary, or Ruby hash. Sets are an unordered collection of unique elements. All of those are basic types and have subtypes for specific purposes, such as concurrency, caching, and streaming. In addition to those three main categories, there are other useful collection types, including ranges, stacks, and queues. Okay, as a brief overview, the next three figures show the hierarchy of classes and traits in the Scala collections. The first figure shows the collections types in package Scala collection. These are all high-level abstract classes or traits, which generally have immutable and mutable implementations. All right, so iterable includes all of these, and then we go into the three categories that were discussed earlier: sequence, set, and map. Map, there's also a possibility of a sorted map, I guess, so that's cool. And set also has a possibility of a sorted set, as well as bit set, all right? And then sequence, as they discussed, has an indexed or a linear sequence. Okay. So then this figure shows all collections in package Scala collection immutable, all right? So now we're looking, they've sort of changed the way they're arranged, but that's fine. So the set, we don't show a immutable bit set, but we do, we don't show anything under bit set. Okay, so the set, we have a hash set and a list set. And if we want sorted set, we have the option of tree set. Cool. And then when it comes to a map, we have the hash map, lovely. If we want a sorted map, we can also choose the option of tree map, cool. And then a sequential map. There are options of list map and vector map. That's kind of crazy. All right, then in sequence is the most, and as it perhaps should be. So index sequence, we have quite a few options. We have vector, we have array sequence, we have numeric range, we have string, and we have range. Okay, cool. Oh, this one's a dashed line. That's interesting. Anyway, so linear sequence, we have an option of list, lazy list, and queue. All right, so now if we want to look at mutable options, we can look at priority queue. That's under iterable. Priority queue is an interesting one, isn't it? So let's see. So we have a hash set. So we had a immutable hash set and a mutable hash set. That's awesome. Then we also have a linked hash set, which is also mutable. Off the top of my head, I can't think what a linked hash set. I can't think that I know what that is. Like, yeah. Let's look it up real quick. Linked hash set. Do I want to look at Jeeks for Jeeks? Probably not. Let's look at, let's look at Kotlin. Yeah, love you, JetBrains. Okay, so what do we know about this? Linked hash set. Do we have a description? Oh, maybe this wasn't the place to come. Maybe there's a description way down here somewhere. Well, it seems like it would be helpful if I were about to use it, but I just want a description. Okay, let's see. Let's go back and try Oracle. Okay, here we go. Oh, sorry, my goodness. Hash table and linked list implementation of the set interface with predictable iteration order. Interesting. So that's where I was thrown off a little bit. Oh wait, okay, so set. Oh, okay, no, I shouldn't have been thrown off. That's fine. All right. So then map, we have hash map, we have weak hash map, we have tree map and list map. Okay. Interesting though that list map here in mutable is not under sequential map, but linked hash map is. All right. So and multi-map is shown here. And then for sequences, we have array sequence. Again, we saw that before. We have string builder this time. It's nice that it has a different name to be like, hey, this is the mutable one, and this is the immutable one. We have array deck, so that's new. We have stack, and we have queue, sure. Here's array buffer. Okay, and list buffer. Anyway, I don't know how long I've been here, but it seems like too long. I have got to get back to what I was doing before. So this is where I was. So the thing I was trying to do is I'm trying to select a type for houses. And I think it should be... Wait, okay, so first of all, should it be mutable? Should houses be mutable? I think actually not. Do we want houses to be mutable? We were pretty careful about that, right? By copying it here. So let's choose an immutable sequence for houses. So one of these. Vector? Do we want to choose vector? Let's take a look. Indexed, immutable. Do we need it to be indexed? I think we don't necessarily need it to be indexed, do we? Oh, wait, yes, we do. Because we check the indexes here. So vector sounds like it could be a winner. We do need it to be indexed because of these things we check about adjacency. Okay, so let's choose vector for the houses. Oh, but also, like, when we choose a vector type... Okay, so we can do this. Okay, so let's give it a shot here. So houses, we think, should be vector house. Yeah? Okay, okay, okay. Scala class dynamic field access. That's kind of what we did in JavaScript, right? Which in JavaScript is very convenient. It works well. But not every programming language is the same, of course. So we might be using something like reflection. Let's see what this person says. Yeah, I guess that's fine. So this one says use dynamic. I was kind of hoping that they would have some other suggestion of, like, a different way that they would propose to do it. I don't necessarily want to use reflection or anything like that if it's not necessary, and I don't think it should be. Right? So instead of saying K1, I feel like what we want to do is use predicates instead. So so when we say house K1 triple equals V1, I feel like instead of doing that, this should be like some predicate which will say, oh, the resident equals whatever, right? So let's look at Scala predicate. Scala school, I'll take a look, sure. Twitter, GitHub, IO, Scala school. Okay. Wow. Hey, you know what? I think I'm glad that I had this link. Although, it seems, let's see. How long ago since this was updated? Okay. Let's see here. Let's stick with the main docs that I've been looking at, which are this one. Let me close all these others for now. I'll close everything else. Okay. So it's gonna be a type of a higher order function. And let's see. So map here, cool. It's possible to pass methods. Great. Let's see. Is this the one that I need? Ah, beautiful. Yes, this is what I want to look at. So instead of K1 V1, I am going to say pred 1, and the type is house to bool, I believe, right? Or is it boolean? Scala boolean. Okay, yeah, I think this is fine. All right. Okay, so then if I have a vector, let's look at Scala vector methods. Okay, so Scala book vector class, new version, sure. And yeah, so this is where I had been looking. Now where do, let's see, is this linking to the API docs? Looks like it. Drop for each. Okay, cool. Head, init, iterable factory, iterator, last, length, prepended all, stepper tail, take right to vector updated, concat, prepended all, prepended appended all, add string, and then apply or else can equal collect. Okay, collect looks like it may be a winner. Compose. Count, diff, distinct by, drop while, ends with equals. Oh, filter, okay. Find, flat map, fold. Let's see, is collect pretty much like fold? No, collect gives back a vector, so let's see. Oh, wait. Okay. So fold would be a bit more of a winner. Let's see which of these take like a predicate. Lazy zip, lift, map, max, min by, make string, okay. Non-empty or else pad 2 partition patch permutation reduced. So is reduce pretty much like fold? I actually don't know this symbol here. So fold has a Z best viewers on Streamboo. I don't know about Streamboo. Actually, I've seen that the name Streamboo come up by quite a few people chatting it. So I don't know. I haven't I haven't bothered to visit. My curiosity hasn't exactly been piqued. Same elements, scan left, search, size compare, slice, sliding. Oh, interesting. Sort by, sort with, sorted, span, split at, sum, tails, to array, to list, to map, to sequence, to set, transpose, unapply, apply, aggregate. Okay, so I think we want we want something like fold. I think we just want fold. Probably. So the initial value interesting. So fold by itself won't do it. I think we need to map and then fold, which is fine. Okay, let's just give that a shot then. So instead of saying this, we are going to say map and then map is going to take what? It's just going to take this function, a to b. Okay, cool. So then I want to say what we do is we go pred1 and, or actually, pred1 and not pred2, or, and then let me see, Scala and or not. It is now possible to use and or as infix operators. Is that what we want to do? Probably. So I'm going to say and or pred2 and so what about not? So this is not talking about things that are already defined, right? Compile time ops boolean. I think yeah, I think it is these. I think I was a little misled there. Not Fred. Uh-oh. That's not. Oh, that's doubled up. That's doubled up. Okay. So we would map and then fold. Is it here? Okay. I think this is fine-ish. Oh man, I'm feeling so slow. Just gonna. It's starting to feel like a slog, baby. Okay. It was something here, right? So. So if it takes 2, then we should be fine, right? Okay, okay. Yeah, I guess it's something like that. Okay. Man. So I have def here. Why did I end up with def and not val? Return keyword rarely used. Yeah, fair enough, fair enough. So let's see what it was saying. Try Scala in the browser. Scasti. Okay. Man, this seems like it's gonna be a lot. It was a lot in JavaScript, and I just, oh, man, I'm not familiar with Scala. Okay. Oh man, oh man. Let me review my other Scala code from earlier. It's been a while ago, honestly. I've been at this for so long. 2 months, but man, it sure seems like a while. Let's look at what we did for Hello World first. Okay, so it says object hello world, def hello. Sorry. Equals hello world. Let's look at what we did for circular buffer. I seem to remember this one being completely straightforward. Let's take a look. Okay. Yeah, this is nice. Yeah, I just said return result here. Lovely, lovely. Actually, looking at this makes me feel a bit better right off the bat. So we had some fields in here. Great. Okay. This makes me feel a bit better, but it also makes me think that instead of trying to use predicates, I am just going to do a lot of copy-paste, actually, in this case. So let's go to rule 1. No, let's go to rule 2 first. So instead of doing this, I'm wondering if I'll just have an easier time just doing a lot of copy-paste. All right? So a lot of copy-paste in this context means that I'm going to try to sort of redo the rule house exists for all of these guys. I sort of hate that, but yeah, maybe. Oh, this is really bad. All right. Yeah, I don't know. Yeah, the zebra puzzle is relatively complicated, in my opinion, and it's marked as a hard. Okay, largest series product. What did we do? Oh, gosh. Okay, so that's more than I thought it was going to be. And this one is rather simple-ish, or it should be. Oh, man. I'm happy that the JavaScript worked, but to make it work in Scala, I think is going to be difficult for me. So here's what I'm going to try. What if I refactor this to use just absolute minimum of language features? Like in Scala, do we have a loop? Okay, I'm just gonna go into the JavaScript again, refactor a bit. It doesn't seem like I'm even using a constructor in Scala. So, like, I feel like I should be able to just get rid of the constructor. So I'm going to copy this part. I'm going to say const. I'm going to get rid of that. Going to get rid of this. I'm going to move these other things out, I think. So I'm going to do this. It's not going to be this. It's just going to be solve. Okay. Not big on this track. I think I liked it more before. This one has not grown on me. I think I liked it more when I first heard it. Let me add this to my list to take off the playlist. Our Kiss in May morning. All right. Okay. Ah, This doesn't really fit on the playlist either. I'm starting to think about like maybe trimming the playlist of things that don't necessarily fit. I don't I don't know that this one necessarily fits, right? Like it's Renaissance music or something. It's Henry VIII or something. En Vrai Amore. Anyway. The context of it within the playlist seems a little weird. Like, it doesn't seem like it should be medieval music, but it is. Not medieval, it's like Renaissance. I guess it's quite short, though. Is it? Let's see if I've broken it. That seems fine. Okay, so I haven't broken it. That's good. Have I made it any shorter? I'm going to get rid of all the comments. I don't think they're helping me at this point. So this is excessive, I think. Can we just say if traits length is 0, will that work? Yeah, that's okay. Okay, cool. This part is perhaps a little too much, maybe way too much. JavaScript class method syntax. Let's take a quick look. What if I just say, is that possible? Did I mess that up? I might have. Oh. Unexpected token. Okay, so let me, yeah, it's fine. Okay, so now, anything else? So get solution. Get solution calls solve. Solve calls what? In violation, which is right here, so that's good. And it calls itself. Is that it? It just calls in violation and copy and itself. other than built-in methods. Okay. So then this, of course, calls all 15 of these rules. And that looks good. So these rules up here are the most convoluted bits, really. I'm worried about this Scala one. How much time did I want to give myself total? I shouldn't stay up super late doing this either. It says 5 more hours, almost 6. So I shouldn't stay up forever. I'm already at the 4-hour mark. Shoot. I feel like this Scala one is pretty much the hardest one, and I've saved it for last. Figures. Yeah, I think it figures. Okay. Um, okay, I am going to... I'm going to log off to regroup. I'm going to come back